Why does the reactivity of nitrogen differ from that of phosphorus? Now this is a very interesting question. Nitrogen, because nitrogen belongs to period 2. Now second period elements are sometimes called typical elements. And why are they typical? Because they're different. And why are they different? 4 points. Number 1, small size. Second, high ionization energy. This is for nitrogen. Third point, relatively high electronegativity and absence of D subshells. And when we say absence, it means no 2D subshells exist. 3D is there, but then that is useless because energy is very high. So you find that nitrogen has a very small size as compared to phosphorus, and because of that very small size, there is a special property. What? Nitrogen can form p-pi bonds with other small atoms like carbon, okay, with carbon, nitrogen, boron, etc. Not many in it, largely with carbon and nitrogen. Because of this, now, and can phosphorus do this? Phosphorus can't do this. Even nitrogen can form a very good bond with nitrogen also, oxygen also forming. Like N triple bond N. Very, very good, very stable, one of the very strongest covalent bonds in nature. On the other hand, P triple bond P is very stupid, unstable bond. Phosphorus, arsenic, antimony, etc. they prefer forming only single bonds. Bismuth, that's very different. It forms metallic bonds. So you find nitrogen is capable of forming double and triple bonds while phosphorus cannot, and that is the first very major difference. Reason being small size and high electronegativity of nitrogen as compared to phosphorus. That is why the first difference comes here. Also, when you talk about D subshells, nitrogen cannot expand its octet. So phosphorus can form PCl5, nitrogen cannot form NCl5. That again comes as a major difference. Not just this, when we talk about non-expansion of D subshell, which means that phosphorus can form P double bond O, R, 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 something like this. Trialkyl derivative of this P double bond O. Nitrogen cannot give you similar compounds. Because of this, why? This is a compound in which back bonding is being done between oxygen and empty d orbitals of phosphorus. Nitrogen cannot do this because d orbitals are missing. These, my dears, are the major reasons because of which nitrogen is a very different chemistry as compared to that of phosphorus.